Alright, let's take a look at a question that asks us to find the pH of a salt solution. The question tells us to determine the pH of a 0.2500 mole per liter aqueous solution of sodium hypochlorite. They tell you that that's NaClO, and they give you the Ka of hypochlorous acid. The first thing you need to realize is if they're giving you a Ka of an acid, they're basically telling you in this question that the conjugate ClO is itself a weak base. So the conjugates of weak acids with a Ka are themselves weak bases. So to determine the pH of the resulting weak base or conjugate base, we're basically talking about what happens when a ClO- solution enters water. So we're going to take that ClO-, which is aqueous, and we're going to add it to water. And when we write our equilibrium expression for this, because ClO- is a conjugate base of hypochlorous acid, it is going to take a proton from water and become hypochlorous acid, HClO. Water in this case is a liquid, and when water loses the proton to ClO-, water will become hydroxide, OH-. From here, you're going to create an ice table. Initial, change, and equilibrium. The initial concentration that we have was given in the question as 0.2500 moles per liter. We ignore water because it's a liquid. And we start off with no HClO and no OH- respectively. In terms of the change, we're going to lose X of the ClO-, and we're going to gain that same amount of HClO and of OH- respectively. And so at equilibrium, we're going to have 0.2500 minus X ClO- ions. We're going to have X HClO, and we're going to have X OH-. I want you to note that if hydroxide is produced on the right side of an equilibrium, that is an indication that you should be using a Kb, a base dissociation constant, not a Ka. And in the question, we're given the Ka of hypochlorous acid, which is this value right here. So to find the Kb from the Ka, we're going to use this equation. Kb is equal to 10 to the negative 14 divided by the Ka value. When we do that, we get 10 to the negative 14 divided by, in this case, 2.8 times 10 to the negative 8, which was given in the question as our Ka. And if we calculate this, we're going to get the value of the Kb. And so you'll get something like this, 3.571428 times 10 to the power of negative 7. That is going to be our Kb value. With the Kb value, we can set up a Kb expression for this equilibrium. So looking at the equilibrium itself, the Kb is equal to the concentration of HClO times the concentration of OH-. These are the products of our equilibrium. Remember that Kb is products over reactants. The only reactant we're concerned with here is ClO-. Again, because water is a liquid, we do not include pure substances like liquids or solids in our equilibrium expressions, only aqueous and gases. Using our value of Kb that we just got, we can plug it in, along with our expressions from our equilibrium column, which is X times X over 0.25 minus x. Those are our equilibrium expressions coming from the E column of our table. And to simplify this, we may as well make that x squared in the top. We can also use the simplifying assumption, provided that the initial concentration of ClO minus divided by the Kb value is greater than 100. So we have to check if that's the case. More often than not it will be, but it's still worth showing the math to do this. So if we take this number and we divide it by 3.57 times 10 to the negative 7, to check if it's greater than 100, we're going to find that it is much greater than 100. In this case, it actually gives us 700,000, which is clearly much greater than 100. What that means is we can simplify this expression by ignoring x's that are being added and subtracted. In other words, we can ignore this x because it's being added and subtracted, meaning 0.25 minus some tiny number is basically going to give us 0.25. So we're going to ignore that in our next step to simplify the math and avoid having to use a quadratic. So we're left with this essentially. This is equal to x squared over 0.25. From here, we can multiply both sides by 0.25 to get it out of the denominator on the right. And that's going to be equal to x squared. Evaluate that. So 0.25 times 3.571428 times 10 to the negative 7 gives us this number, 8.92857 times 10 to the negative 8. That's going to be equal to x squared. So to get x, we're going to square root both sides, and that will give us x. In this case, x equals 2.988 and some change times 10 to the negative 4. And if we go back to our equilibrium table, we can see that x corresponds to the equilibrium concentration of hydroxide. That is the concentration of hydroxide ions in our solution. Remember that the question originally asked us for the pH. But with hydroxide, we can't find pH directly. What we have to find first is the pOH. And to do that, we're going to negative log the concentration of OH minus, which again is what we just got here. X is the concentration of OH minus at equilibrium, so we're going to negative log it to get the pOH. So I'm just going to negative log the number I currently have in my calculator, which is this, ... times 10 to the negative 4. So when we negative log it, we're going to get some number, which I'll tell you right now is 3.5246. And we need the pH now. So we're going to do 14 subtract the pOH. In this case, that's 14 minus the number in my calculator right now, which is 3.5246. And that will give us 10.47539 ... Or, looking back at the original question, we were given 2 significant digits here and 4 significant digits here, so we can only really give back 2. Technically speaking, this number would have been 2 significant digits, and so when we subtract 2 digits, like 14 minus 3.5 for example, we would keep the lowest decimal place, so we're going to keep our answer as 10.5, and that's the pH of our solution. Does it make sense? Well, we said at the start that sodium hypochlorite rather, contains a conjugate base. We said that this is basic. So the salt NaClO must be basic. In other words, the solution that we get when we put this in water should be basic, and a pH of 10.5 implies a basic solution, so the answer makes sense. Hope that helps clarify things.